Okay, 3.8, instantaneous acceleration. This is very important. The first thing here, guys, is we have dealt with mostly constant acceleration up until now, but not all acceleration is constant. So before, say you had a velocity time graph like this, and this was a straight line, and if we wanted to determine what the acceleration was, we dealt with something called average acceleration, which is simply delta v over delta t. And so if you've got your, say, t initial, t final, then we calculated v initial, v final, and we had this triangle, then basically we know that the basic idea is that acceleration is the slope of this curve. So because there was a constant slope, we could get away using an average velocity, average acceleration, which is delta v over delta t. Okay, because any acceleration in between here would be the same. Now, what happens if you've got a velocity curve that looks like this? It's not a straight line, and there is no constant slope as I move along the curve like this. So if I want to find out what is my acceleration at this point, if we use this approach, we say have a specific time span. So time equals 10, time equals 35, and then at time equals 10, I've got my velocity initial, and at time equals 35, I've got my velocity final. If we use the average acceleration technique or way, then that is our acceleration there. That's our slope. Our slope then, using this large time span, is the acceleration. And as you can see, we know that the acceleration should be a tangent at point P. So how am I going to get this tangent? Well, what I can do is I can keep making this delta t smaller, right? Smaller and smaller. So now you can see the tangent there, that line, sorry, not the tangent, that line there is approaching the tangent. Then, if I make the delta t even smaller, then that line is approaching the tangent. And so this is essentially what we're doing here, is we're saying, let's make delta t smaller and smaller and smaller, and let the delta t approach 0. Let this delta t approach 0. And as you approach 0, in the limit, you obtain an instantaneous acceleration, which is essentially the tangent at that point. And this is what we have here. So whereas before we had average acceleration, which was change in v over change in time, delta v, here we have instantaneous acceleration, which is the derivative of your velocity function. It is the derivative of your velocity time curve, which essentially means it is the tangent. It's the slope at that point, and it is instantaneous. So now, using this, we're able to find out what is the acceleration at 10 seconds. We know that the acceleration is different after 10 seconds and before 10 seconds, but what is it at 10 seconds? And what is the acceleration at 20 seconds? This allows us to calculate the slope of the curve. Okay, see you in the next video.